All right, in Core 3 today, we are continuing our work with circles, their tangents, and their chords. Today, I wanted us to look at two real-life examples, one involving tangents, one involving chords, and using this knowledge to help us solve problems that we've already been kind of able to solve. So let's go ahead and take a look. First problem we are doing is from page 400, and it is the check your own understanding problem. So it doesn't really have a problem number, it's labeled check your understanding. This is what it looks like. Check your understanding. Now, this problem is talking about the Earth, so a nice big circle. There's the Earth. It says the middle is the North Pole, and we have a satellite somewhere out here. We'll label that point S. The satellite has a viewing angle that ends up being tangent to two parts of the Earth, creating the kind of diagram we've already been working with. Now, the problem tells us that the viewing angle of the satellite is 50 degrees, and that the radius of the Earth, which I'll draw this out to the point of tangency, is 3,963 miles. I'm going to go ahead and draw the other one. $3,963 miles. Now we have the kind of diagram we've been working with. Okay, but in this case we have the Earth and a satellite, so it's actually a real-life application. Now, we're asked for two different things. We're asked, what is the distance from S to the location along the equator right there? So we're asked for that distance. I'm going to label it X. And how far above the Earth's surface is the satellite? So that is a straight-on line right here. Now, we have to be careful. We're not being asked for this entire side length. We're only being asked for the distance from the satellite to the actual Earth. So we'll call that Y. Doesn't make things any more complicated, just slightly trickier, because we know this portion, that's a radius, 3,963. We know this is a right triangle, therefore it's just SOHCAHTOA and Pythagorean theorem once again. So, let's go ahead and solve for X first. First of all, I'm just going to sketch our triangle off to the side. We know that's 3,963. X, and this angle right here is 50, therefore half of it is 25. Now, if I use 25 as my theta for SOHCAHTOA, then I have the opposite and the adjacent. That means I am going to use tangent of 25 equals 3,963 over X. Now, we've looked at this before, that when you have a problem like this, you can swap the trig sign with your variable on the bottom, and it becomes X equals 3,963 over tangent of 25. Break out your calculator. First of all, let's double check, make sure we're in degree mode. We are. Here we go there, press enter. Now, 3,963 divided by tangent 25. We get 8498.68. And that's in the unit miles. That makes sense. If we're talking about the Earth with a radius of almost 4,000 miles, then this length looks like it should be about 8,500. So that makes sense. Always good to look back and make sure your answer makes sense and make sure it's not just gibberish. Now, let's try and figure this part out. So to do that, we have to come up with this entire side length. Now that we have two side lengths, it's just Pythagorean theorem. We'll have A, B, C that we're solving for. So 3963 plus 8498.68, both of those squared, will equal our C squared. Once again, that's a simple calculator step. 3963 squared plus 8498.68 squared. I get a nice long number. 8793293.74. 87 million. That answer would not make sense because it's not right yet. That is what C squared equals. So we want to take the square root of that whole thing, and I get 9377.25 miles equals the entire side. Now we have to be careful. That is not our answer yet. That is the whole thing from the satellite to the center of the Earth. But we want the satellite to the surface of the Earth. So we take our number here and subtract the Earth radius, 3963. And we get 5414.25 miles. And that's our Y. Now, that answer does make sense. Because if we're considering the distance of satellite from the surface of the Earth, 5,000 miles probably makes sense if the Earth is itself already 4,000 miles deep. Now, this is as far as most of my classes got, so this is as far as I'll go for now. We will do more of this on tomorrow.